Hey, so I've decided to make a roguelike game. I've had a working map generation, but it was quite bad. To make it look better, I started from scratch. In this video I will explain how this dungeon generation works, so you get an idea how it can be programmed. I will probably improve this generation later and make it look something like that. So stick with me and you will learn how a hopefully good looking roguelike is built. Now let's get to the code. First, we call our constructor and overgive the size of the map and the borders, which are essentially the borders of the dungeon. Then the actual dungeon size is determined by the map size minus the borders. To create the dungeon we have to spawn the rooms. Here we overgive the minimum and the maximum possible size of the room. In the function we make sure that the number of rooms will fit into the map. The first room always spawns in the middle of the map, so the dungeon will always spread from the center. Let's get now to the actual function where the room gets spawned. Since we overgave the spawn point of the room, we get into here and right away decide the random size of the room between the values we overgave. Down here we make sure that the room spawns exactly in the center. After that we go through the room and add the positions and the according tile types to our dynamic array. If the coordinates are positioned on the borders of the room, that means that they are walls. Next we want to store the points where the connection between the rooms can occur. A room has 4 sides on which a connection with another room could be potentially possible. So every room has 4 sides and every side has X amount of walls. If the coordinate is on a corner of the room, then we continue, because the rooms can't connect on these places. So next up we want to store the positions where another room can spawn on. If the current position is near the corners of the room, we skip this part. Or in other case, if it's a wall, then we add a floor tile to the room. We have a dynamic array which stores the inner part of the room. If that part is completely overlapped by another room, then the room can't be spawned. With that we prevent the dungeon to look dense. The spacing is the gap between the border and the inner space of the room. And if one of these conditions are true, then that position is not the inner section of the room. If we don't overgive an initial spawn position, in that case we create the size of the room randomly as before, but this time we take a random wall from the previous rooms and take that position as the spawn point of the new room. We also decide in which direction the room will point here. We repeat this process until the room can be placed into the map. This condition is not that necessary to check, but I found out that it makes the map look a bit more interesting. Let's now dive into this function. Here we first check if the room would not end up outside of the dungeon's boundaries. Next we loop through the room and check if it is too close to the neighbor's room. If it is, then the room can't be placed. First, here we go through all the existing rooms and then we go through the room's positions, which we then compare to current room spawn position. If the positions match, we go in and loop through the inner section of that particular room and check the same as above. Again, if it matches, we erase the part from that inner section of the room. We do the same for the room's position. Outside of the second loop, we look if the inner section is empty. If it is, that means that the new room completely covered the room's inner section, which means that the new room can't be spawned. If everything went fine, the room can spawn and we move on. Now we have the shift part. This function centers the entire dungeon, so it looks very nice on the map. In it, we search for the dungeon's left, right, down and up point. We then get the difference between the dungeon's maximum and the actual size, which is the span. We now use the spans to shift the whole dungeon till it's centered on the map. We take the difference between 2 points on one axis. If the difference is equal to 0, 1 or -1, then it means that the dungeon is already centered on that axis. But in other case, we check if the difference is less than 0, we decrease the left span and increase the right span, which means that we have to shift the dungeon horizontally to the left. If not, then we shift it to the right. The same applies to the vertical shift. After that we finally can add all the rooms to the map. We should not forget about the dungeon's borders and the shift that we just calculated. Next function is the fill out space. It fills out the holes in the dungeon. In it we go through the map, and if we spot that there is a potential hole in the map, we try to fill it with the floor. We get into a loop which starts at the beginning of the horizontal position, and we go until the end of the dungeon's width. If in this range a wall comes up, then we can assume that there is a hole that we could fill out. So we add the empty space of the starting position. Then we get to the recursive part, where we try to fill out the empty spaces. We try to open a space on the left, right, up and down. This valid space means whenever the hole is valid. As soon as we find out that it's not a valid hole, we set the boolean to false, which results in returning completely back to the first function call. Also, we clear out the dynamic array, which we thought before would be a hole that we could fill out with floor. Back where we left off, if the position is a wall, then we return. Also, in case the hole is still valid, but if one of the previous spaces is the same as the current, we go back. At the end of the function, we add the position to the spacing, and we call the function where we again try to open empty spaces. Like I mentioned before, this loop of function calls ends whenever the overgiven position is out of the dungeon scope, or if all the positions of the hole are already saved into the dynamic array. Next up we have this function, in which we will spawn the doors. Do you remember that we have a dynamic array which stores the rooms for wall sides? Yeah. Now it's time to place a floor on each of the wall sides, if it's possible. So we loop through all the wall sides of each room. We then get into another loop which ends whenever we find a wall for removal on the current side. C is the index of the current wall on the side. And in case C doesn't equal to the initial value, that means that we already looped once here. Which also means that the wall wasn't a valid connect point, so we erase it from the dynamic array. If there is no wall left, we break. In other case, we randomly get a wall out of the available. And then we look if the wall doesn't face any empty tile or a wall. If it doesn't, we can safely replace the wall with a floor tile. Now, finally, it's time to look into the last function. This function erases the lonely walls, the double walls and the small gaps between two walls. Here we are going through the map and we are looking for the small gaps. As soon as we find one, we change it with the floor tile. Next, we remove the double walls. We do that by first looking for the neighbors around the current tile. If there are 3 neighbors, that means it's a double wall. Here we start to count the amount of floor tiles around each of the 4 walls, and the wall with the most floor tiles will be erased, but there are some exceptions. Lastly, we erase the lonely walls. That's it, thanks for watching, don't forget to like and subscribe, comment below if you have a question, I will answer it.